I'm Professor Stuart Tangye. I'm a Senior Principal Research Fellow here at the Garvan Institute of Medical Research in Darlinghurst, Sydney. And I have been interested in immunology and cancer research for many, many years now. When I was growing up, I really wanted to be in the police force, actually. But those were the days where you had to be a particular height, so I was too short to ever get into the police force. And then I really liked science and medicine, so I thought I'd think about medical sciences, medicine, but I didn't get enough marks in the HSC, so I was too short to be a policeman and not smart enough to do medicine. So I ended up doing medical science at university. I went to University of Technology. So I did a 3-year Bachelor of Applied Science in Biomedical Science. And I still had aspirations of somehow getting into medicine, but it became pretty clear that that wasn't possible. This was the days before graduate medical program. But fortuitously, in my 3rd year of undergrad uni, I had some really dynamic lecturers in immunology. And immunology was one of those fields which were still relatively young. This is the late 80s, early 90s. So it's like many disciplines, had been around for a while, but unlike biochemistry and microbiology, which at least from the lecturing perspective, didn't feel like there was much dynamism there or much new stuff happening. Immunology was really the unknown, and you'd ask your lecturers questions and they didn't know. And it's not that they didn't know because they didn't know the field. It's just that we didn't know as a field. So it was really intriguing to me. And that was the turning point, I think, when I decided to give up on my aspirations of doing medicine and focus on medical research instead. So I went about doing an honours year, so a 1-year research program in immunology. And then that became the grounding, I guess, for my PhD, which I then undertook in the field of B-cell malignancy, actually. So I studied B-cell leukemia. So I've always worked as part of a team in one way or the other. So when I was more junior, I worked in someone else's lab, and I did that in the US, and then I came back and joined another lab in Sydney. But after a number of years of doing that, I established my own lab. And like everybody, when you start out pretty small. You attract 1 or 2 students or 1 or 2 research assistants. But now, having been doing this for 25 years or so, I have a pretty strong team of people at all levels. So undergraduate research students, PhD students, research assistants, postdoctoral research fellows. I also have non-scientists in my team, so people who project managers and so on. But one thing that I've done, which is really important for research in general, but particularly what I do, which again is studying these rare diseases, is you've got to build networks, you've got to build collaborations, and you've got to build trust and earn trust in people. So I work with a lot of people out in the clinic. I'm not a clinician, so I need those clinical contacts because all of my work is human focused. So I work in so on my day-to-day job here, I have a team of about 10 people. But really, that's sort of my base, and the real work is done globally. So we collaborate with clinicians in the hospitals here, hematologists in the hospitals here. But again, reflecting on how rare some of these conditions are, we have to work, and happily, not have to, but happily work with colleagues in Japan, in the US, in Europe. And that's terrific because it gives you opportunities to see how things are done elsewhere. I've gone and worked in the US again in my later life on sabbatical to do a lot of work in that space myself. So that teamwork, that collaborative work, that sort of crowdsourcing of research is really important these days because fundamentally, while I've been doing this for a very long time, and my lab is very good at what we do, which is human immunology, cell biology, we can't do it all. We can't do the genetics, we can't do the high-level bioinformatics and things like this. So we need collaborators, and you need to have really good people around you to bring all that work together. It's like solving an incredibly difficult jigsaw puzzle. Some people are really good at doing some parts, other people are doing other parts. And you've got to bring it together collectively, collaboratively, and collegially to put all those pieces together to actually understand the story and to make those important breakthroughs. It's very hard to do all that in your own backyard. And it's actually, I think, counterproductive and not a good use of your time or the people that you work with time or even the funding to try to keep it all under one roof. You really need to have that collaborative network. And that's the terrific thing about science. We're driven by passion, we're driven by discovery, we're driven by intrigue and curiosity. And to find like-minded people, whether it's here or overseas or on the other side of Australia, it doesn't really matter. Science is so connected, and it's a bit like music. It's a universal language. You can talk to anyone, anywhere about anything, and you can find that sort of kindred spirit who wants to join with you on that journey and that pathway to discovery. Essentially for the same reason, which is, in my case, to just improve understanding, but really convert it to some type of better outcome for humankind. Science is terrific. There's no doubt about that. This may sound strange, but you live and die by your own decisions. So I'm independent in the fact that I'm doing the research that I want to do. So you've got to stand by that or fall by that. And hopefully you can bring people along with you and convince them that what you're doing is interesting and they want to work with you or they want to fund you. So that's really exciting, is the fact that I'm incredibly autonomous in what I want to do. I'm not held by some overarching mantra or goal of someone else. So that's great. It's also terrifying because it's all up to me. I really love the collaborations that I've established with people near and far. And for better or for worse, COVID sort of whilst it kept us all apart, it actually brought a lot of us together as well. And that really showed the excitement and the collegiality within the research community when you've all got a common focus or a common vision and you want to share that with others. So I really love that aspect of almost unbridled collegiality and desire to work together. Now, of course, science is incredibly competitive, so not everyone's awesome to work with. There's hard heads or competition within that space, like in any field. But if you can find the right people to work with, that's what I found really exciting. I really enjoy having students come into my lab, so young people who want to learn and be trained in the field that I'm really interested in, which is immunology, immuno-oncology, cell biology. So I really love having PhD students coming in and then watching them grow themselves and mature to become someone who was fairly, I wouldn't say lacking confidence, but unsure of how to do things and how immunology works. Over time, just watching them develop and grow and mature as a sort of free-thinking, clever, dynamic, very efficient scientist in their own right, and then sort of watching them go on to do the next thing. So having trainees who go on and do things is really gratifying. We do get to travel a little bit. That sounds probably incredibly vain or overly romanticized, but you do get to visit some pretty amazing places. But again, it's on the back of the science. You see people, you make friends, you catch up with people. And you can do that along the way, which, as a young kid growing up in the suburbs of Sydney, I never thought I'd have these opportunities to travel the world on the back of my work for the reason of conveying my message to different communities, different parts of the world. Well, it should probably take a lot longer than I give it because we're pretty time poor, so I often leave things at the last minute. But really, I usually put 3 to 6 months into planning a grant. So when I know a grant's due, I'll start sort of conceptualizing it or writing it, just thinking of how I'm going to structure it. It sounds a bit academic, but I spend a lot of time thinking, so it may not look like I'm working on a grant, but I take a lot of time to try to visualize, contextualize how I want to pitch an idea, because that's what a grant's all about. It's a bit of a sell, and I don't mean that in a cynical way. You've really got to have a structure by which you want to convince a whole lot of people why your idea is better than 90% of ideas. Because unfortunately these days, at least in Australia, the funding rate is very, very competitive. The funding landscape is tough. 10 to 15% success rate. So you've got to work out, well, how am I going to convince my peers that my idea is in the top 10%? So, you've got to be really creative in a scientific way. You've got to be really articulate in conveying your idea and your message. So that's why I have put a big lead time into it. But I spend a lot of time thinking and conceptualizing. And then I probably spend, a solid 2 months writing the grant. And I sometimes think scientists are probably a little bit like artists or writers or poets or songwriters. There's a lot of drafts. You write something and then you save it and then you come back to it later on and you rewrite it or you rework it or you use it at another part of the grant. So there's a lot of articulation, I guess, and structure and construction in putting a grant together. It's a real artwork. Grantsmanship is really tough, and you've got to learn how to do it really, really well. And luckily, I've had some terrific teachers in that space. but it is a tricky thing to do. You've got to be really good at writing. You've got to be really good at creating a scenario and indicating why this is novel or why this is going to change, make it an impact. And also, you've got to then try to ensure that you're going to be able to deliver on what you're essentially promising to the community, to the research field, to the consumers who are involved, to the patients at the end of the day. So I actually like grant writing because it gives you a chance to step back and look at the much bigger picture, because on a day-to-day basis, I'm incredibly busy. Meetings, students, Zoom calls, administrative obligations, things like that, which are not so exciting. So these days, unfortunately, scientists are very time poor. So grant writing really makes you stop and step back and go, this is the big picture. This is my palette. This is my landscape that I'm working on. How am I going to build this? So grant writing is as challenging and as time consuming as it is. It actually makes you stop, make me stop anyway, and think, what am I doing? How am I going to do this? Is this the best I can do? So it's a bit of a reflection point on making sure you're being true to yourself, being true to the science, and you are on that trajectory of trying to bring novel ideas or make novel discoveries, so it will just make things better along the way. Yeah, there's a couple of those. I remember when I was working in California, working on my doing my postdoctoral training, there was one of those times when it was a really eureka moment. I was doing an experiment, and it was actually to do with the way the immune system would interact with cancer cells. Would immune cells be able to kill particular cancer cells in a particular way, and so on? And I was studying one of these patients who had these susceptibility to Epstein-Barr virus infection and developed cancer. And what we showed was that their what are called natural killer cells, that's an type of immune cell, failed to kill this B-cell malignancy. But the thing was, I was watching the results literally come out of the machine, a bit like on a receipt that you get at the cash register these days, watching these numbers pour out of the machine, and you're sort of looking at them, and then you realize you could actually interpret it as you go. And it was a really eureka moment thinking, wow, that experiment actually worked, and that experiment has actually told me something that we did not know before. So that was a really eureka moment in my sort of training time. But these days, with this big network we've established, this collaborative immunogenomics research program that we've established, what we are seeing there is we're trying to diagnose patients with these rare diseases and then let that genetic information inform the clinicians of how best to treat those patients. And again, I'm not a clinician, but I'm part of that discussion with the clinicians. And what's really exciting is when we can discover a genetic change in an individual, that can lead the clinicians to give a diagnosis. And those kids can then undergo their right treatment. And they're not trivial treatments. It can be something like a bone marrow transplant. But having seen some of those kids, not necessarily literally seen them, but be hearing these stories of how unwell they were, of how life-threatening their condition was, how severe they were, how in and out of ICU they were. And now they've sort of come through that research program that we established, and they're now on better treatment, or they've been cured because they've had a bone marrow transplant, for instance. That's pretty gratifying, particularly for someone who wanted to do medicine, and I feel I'm doing the best I can from my position. And that's incredibly rewarding to see these outcomes. And again, I've got 3 kids myself. I think having a sick kid would be devastating and very difficult to cope with. So we're not just talking about one individual being affected. There's a ripple effect. Parents, grandparents, siblings of unwell kids with these genetic diseases. It's a huge impact on the society, on the family unit, and so on. So to see that change that we can bring about through genetics, through research, through diagnosis, and by implementation of the best treatments, that's got to be the most rewarding thing about medical research. Seeing those changes in real time and in a relatively short time, that's pretty satisfying. I think, speaking for myself, purely for myself, but I think this is applicable to a lot of scientists. We're pretty nerdy. I'm interested in a lot of quirky things. I love nature. I love getting out amongst it. I love the beach. So I really like bike riding. I love swimming. I love surfing, going to the beach, those sorts of things. I've got 3 kids, so they're growing up now, but they've kept me pretty busy for the last 17 plus years. So I really embraced being a dad and seeing that whole change of my life when I was in my late 30s, when our first child was born. So I really enjoy doing stuff with the kids. That's getting a bit less now just because they're getting a bit older and their dad's not so cool anymore. But I like pretty regular things: bushwalking, like reading. I've always loved music. I really like live performances, live music. So I started playing the guitar about 10 years ago for my own benefit. So that's something I really enjoy doing in my own time. But anything to do with creativity, curiosity, nature is pretty relaxing for me. I've been lucky to travel to a lot of places, but a place I've never been to is Alaska, and I think I'd really like to get up to Alaska someday. I'm not sure when or how, but I think that would be a pretty spectacular place to visit.